Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial 77, we started integrating Earth Engine with Excel and QGIS. In particular, we generated a feature collection from the coordinates of a polygon. We generated time series data for each of my 100 points for those data sets that are in time series format, like my climate data, maximum temperatures, minus temperatures, the snow cover, normalized different snow index. So we generated the time series data for that, and then we generated median images for most of my time series images and some reduced image for snow. And then we generated single images for those data sets that only have single images, for example, elevation, slope, etc. And we exported everything to my desktop, my Google folder drive. And from Google folder drive, I opened up everything in QGIS. So this is roughly what I have at the moment in QGIS. I have my snow cover. Okay, first of all, let's put it this way. I have my 100 points. Okay, there's my 100 points. So if I open that and I go to open attribute, you'll see, once it opens, you'll see there's the points, and it's from 1 all the way down to 100. So that is the 100 points here. Close. That's 100 points. Okay, so that's important because I want to generate information for these 100 points, not for my region of interest as a whole, but for these 100 points. Then I have my snow cover image. Remember, this is the sum image of all the snow cover from February 2000 to December 2023. So that is that. Now, as I said, if I go into the properties of it, you'll see I've started there with 100 because I'm only interested in those locations that recorded some snow, not locations that didn't record any snow. So that's why I've used 100 as an arbitrary number. Now you can play around with that number. That's totally up to you. You can make it bigger, you can make it smaller. That's totally up to you. But just overlay that number with the image of actual snow to make sure you either don't include areas that didn't have snow or ignore images or locations that did experience some snow. So play around with that 100 number, but yeah, and that is my color scheme that I've used. Again, these are totally arbitrary, totally up to you as an individual, but as I said, there must be some argument or some logic behind your choices and your decisions. Okay, so that's that. Then I've also, as I said, brought over my normalized difference snow index, and this is a medium number. Okay, and again, I played around with the index colors, and again, you can play around with it. There's the numbers. Then we have, and again, remember this is a median number, because it's also, I think, from February 2000 to December. So this is a median number reducer as well. Here's my maximum temperatures. Obviously, you can see there the red. Sorry, I'm putting minimum temperatures. The maximum temperatures there. If I open it, sorry, you'll see the red is 29.3 degrees Celsius, and the blue is the 18.2 degrees Celsius. Now, just interesting in here, this is why I said I didn't do a randomized 100 points, because I specifically wanted locations that were covered, that were very hot, and you can see as locations where it was very cold. If I did a random 100 points, I may not have any locations that has extreme cold, or any locations that had extreme red, because it's random, and it's so the random would be, you know, equal chance of getting it. Here I didn't want random, I wanted the specific locations, because I'm interested in X amount of locations where there's no snow and X amount of locations where there were snow, and then compare the two, you know, like a sample. to equalize samples. Okay, so that's maximum temperatures. There's my minimum temperatures. And you'll see here, the red is again high temperatures, high nighttime temperatures, and the blue are low nighttime temperatures. Okay, so that's I've done there. So I brought that. Remember, this is still median. This is still median. Rain. So that's my rain. So areas with dark blue receive very little rain. Areas with yellow received a lot of rain. Okay, so that's evident there. Then I have wind speed. Where's wind speed now? Where is the wind speed? Oh, goodness Christ. I don't have wind speed here. Must go and find it. Oops, forgot to include the wind speed. Okay, better. Let's see if I've got it. So we're going to go to layer, add raster layer. I'm going to go and look for it in under my view from space. Let's have a look and see. It should be here. No, that's wind speed. There's wind. And I open it. I add it. Okay, let's bring it down into its rightful place somewhere here by rain. There is wind. Sorry, man, I had wind. How did I look wrong now? Remove layer. Sorry. It was there all the time. I looked for, okay, I don't know what I've looked at. There's the wind speed. Just have a look at it. Red is high wind speeds, locations with high wind speeds, and this purple gray areas of low wind speed. Okay, so that's my median images. If I just want to highlight them all, so those are my medium images, environment related, spanning a period from February 2000 to December 2022. Now, as I said, what I did is to get the 2023 numbers, I just used the 12-month moving average in Excel. So I generated hypothetical numbers for 2003 based on a moving average, a 12-month moving average from 2022. Okay, and again, it's just for illustrative purposes. I'm not trying to do it as accurately possible, but obviously if you do it, or if you want to do it for a paper or for proper analysis, then there has to be reason of what method you're going to use to generate those outstanding numbers. In the absence of actual numbers, you have to model the numbers. You can either use moving average methods or some like a RIMA model or whatever the case might be, but there has to be some reason. I just use a 12-month moving average. Okay, and those are median images, etc., etc. Now, as I said, I have generated time series data for each of these variables for my on-it locations. Okay, because we did that in Earth Engine. Okay, so that's I'm covered with. So snow locations, snow cover, that one there. Normalized difference snow index. Let me highlight them just for simplicity. So all these variables are in time series format from February 2000 to December 2023. So I generated using the triplet script. I generated time series for these 100 points. The ones that were in daily format, like the snow cover, it was daily. I converted into monthly. So they all now are on monthly. So they have the actual numbers. Okay, so they have the actual numbers and they have the 4 descriptive statistics, remember, within the database. Okay, so in Excel, if I might just go to the last one, you'll see all of them. Like here's wind speed. All of them, remember those are the variables that I just highlighted. All of them have 4 descriptive statistics, which is a sum, average, median, and a coefficient of variation. So that's for wind speed. If I go to PR, which is rain, participation, sum, average, median, and coefficient of variation. So there's all of them, snow cover, etc., etc. So if I correlate that now with this one, I said all of these images are time series, but I do have descriptive statistics for each of them. And as I said, the purpose of that is because my slope, my elevation, my hillside, my aspect, my terrain, they don't have time series. They are singular number. Okay, one number, one location, that's it. Okay, so I cannot compare this analysis in time series format, because those variables are only once-off variables, singular variables. So that's why I've created singular variables for these time series as well. And I can either then choose the median image or the mean image or the sum image or the coefficient of variation data or series to then add to these four. Yeah. I hope you're starting to get the idea. Okay, so then I have my slope. There's my slope. Okay, and it starts from 1, which is here at the bottom, 1 meter above sea level to about 80 meters. Oh, sorry, this is degrees, 1.8 degrees, and this is 7.9 degrees. So that's red is very steep, and bluish colors are fairly flat, very little slope. This is elevation. Just to go through that, so this blackish color is 1 meter above sea level, and this white color is about 2,000 meters above sea level. Okay, so I've got the slope, I've got the elevation, and this is my hillside. This is whether in what degree, whether it is on the dark side or the bright side of the mountains. That's what the hillside is how much time it has sunlight, or is it bright. Okay, so that's it. So you'll see there 1 to 155. The yellow is areas that have very little light, and the purple, dark purple, black areas are areas that have yes, it is like that. Yeah, correct. Okay, so we can just cross-reference it. So if I check that, yeah, you see, sorry, the dark blue, this area is here. So if we go in, I had it the other way around. This dark bluish areas, if you look at it, those are areas that have received very little. No, sorry, the dark yellow. So the dark yellow. So I press on that one there. Let's press on dark yellow. You'll see it's got a slope. Sorry, hillside. Must highlight the hillside when I do that. You see, hillside is 255. If I go to the dark, you'll see the hillside is 2022. So the dark yellow area is close to 255. That's area that has very little sunlight. So it's dark most of the time. Let's have a look at, just confirm. You can see if I go in, go a bit closer. Let me just get my hand up. You'll see this is areas that receive very little sunshine, and you can see it is this yellowish area. Okay, so that's the hillside, and then you have the aspect. It's just the aspect is just which side, what does it face. Okay, and that's degrees from 0 degrees to 360 degrees. Okay, so does it face north, south, east, west? Where is this mountain facing? Okay, so that's what the aspect is. Okay, and you can cross-reference it, and that's why I've included the Esri satellite image. Now, they may not always be 100% correlated, because the Esri satellite could be a different time period for which my elevation, hillside, and aspect. So that's why it's never going to be 100%, except if it's exactly on the same date. But this could be different seasons, so therefore the sun direction obviously is different, and therefore the hillside may not perfectly correlate with the hillside on the Esri with the hillside image itself. So just bear that in mind. There is anomalies, but plus minus it's going to be fine. Okay, so obviously this is also my region of interest. Sorry, come on. This is also my region of interest. Okay, so that's my region of interest, and that is my 100 locations. Now this number here, the snow area number here, it's okay, sorry, the terrain here, sorry, let me go there. That is 3 bands that I've combined using my it's the align rasters. It's not align, it's conversion. Build virtual raster, virtual raster builder. Okay, so you combine the 3 rasters, and you can combine any 3 rasters, and it gives you some interesting pictures. And yeah, we're going to get to that at some point. Okay, so you can see that the locations are evenly distributed. So the idea now is to go and generate the topography data for my locations together with the time series data for my locations as well. And for that, I use the sample raster function in QGIS. Very neat, very handy function. Okay, so let's just quickly go and let's say this is as a demo. I've already done it, but let's say as a demo, I'm interested. There's my locations. So there's my locations behind it. I'm interested to generate the median rain participation value for each of these based on this image. So I use my raster. Okay, so I'm going to use my locations, which is these 100 locations. My raster layer is the rain, and I'm going to give it a name called the rain, and it will generate the corresponding value. Remember that will be a median value. Okay, I'm not going to save it now. I'm just going to, for illustrative purposes, run it, and there it sits. It's a temporary file. If I open it, right click, I go properties. Sorry, that properties, attribute table. There's my attribute table. You'll see there's my locations, 1 to 100. If I go first to the right, you'll see there's the rain. So location had a median rainfall of 29 millimeters. Location 2 had a median rainfall of 27 millimeters. Location 3, 29 millimeters, etc., etc. I can just go there and I click on it. I can make it, I can order it from low to high or from high to low. So the highest location had a median rainfall of the monthly rainfall. Let me convert correctly say. Remember, our median function is on the monthly images for that period from February 2000 to December 2023. So that's X amount of images, X amount of time data set, data points. And I get the median. So 32 is the median monthly rainfall for that location. Which location is that? That is location, this one. So let's quickly highlight that and see if we can see where is that location. There it sits. You see it's in yellow. So it lies within that yellow part. So if you go to rain, that's the area with 32 millimeters of rain, which is that area there. Okay, so it corresponds 100%. So that's why using the sample raster value, I can put generate the individual data value, the median data value for each of these, for each of those variables, which is quite neat. Yeah, very, very neat. Okay. So what I have at the end of the day is I've got a data, polygon, a point vector, or point polygon. And if I go to open its attribute table, you'll see it's got the X and Y coordinates. It's got the point. Remember that it's very important. And then I brought in, you'll see the snow sum, snow average, snow median, snow coefficient of variation. Remember that I've generated in Excel. I brought that in. Then I've got maximum temperature sum, blah, 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 blah. Minimum sum, minimum average, minimum medium, etc., etc. And then, as I said, and there's my wind speed, the 4 very descriptive statistics, and then there's my elevation statistic, my hillside, my aspect, and there's my terrain again, which is again the elevation, but it also brings in the slope, which is the which one is the slope again? I think it's the 139. Is the slope. It's somewhere here. And then okay, I'm not gonna, don't worry. And then I've got the normalized difference snow index. I've got its value there. So now I've got I've populated all the data for these 100 points. I've populated the snow related data. I populated the environmental related data, and I populated the topography related data for each of these locations. Okay, so let's, for example, say I look interested in the snow cover. Okay, so let me go there. I just want to take that off. Okay, so there's my snow area. You can see there's my snow covered areas. So let's say I want to see whether there's a, well, what is the, let's call it the slope. So I'm going to go graduate. Okay, I'm going to go to slope. Well, I don't have the slope. I think let's go elevation, height. Okay, so purple is from 67 to 488. So you can see this red, brownish red is very high above sea level, whereas the purple is very low on sea level. I press apply. So let's have a look and see. Let's just open it and open it. Sorry. You can see that the height, so it's yellow and brown. So it's these ones. So if I, okay, let's go. You can see, it's difficult to see now here, but the purple, the low-lying areas, no snow. So, okay, so you can see there's no snow on those areas. Then the blue, also no snow on those areas. And then the green, there is, I don't know why it's giving me that color. You can see from the green onwards, from about 1,000 meters up, there seems to be a little bit of snow. But the main snow lies within 1,300 meters. Okay, you can see there, where's, yeah, sorry, let's go. This is a good example. You'll see it's red, and so this is thick snow. You can see it's the yellowish, that yellow. Thick snow, it's all about 1,700 meters and above. So now we can, for example, infer that these snow areas, so locations with a height of 1,700 meters above sea level, they get snow, or they're likely to get snow, etc., etc. Okay, so we can play around now in QGIS and derive all sorts of things. We can use R in QGIS to calculate. So what I want to do now is to say, okay, now we've got all this information. Okay, we've got all this information. I have a point layer with attributes, and this attributes includes the location. It includes a random number, which is basically just a number from 1 to 100, but randomized. And we've got all the data from my variables. Okay, for my time series variables, I've got 4 statistics, and for my topography, I've only have the actual value. Okay, so I basically just export this into, so I go there and I go export and I go save feature as, and I export it as a CSV file. Okay, so I export it as a CSV file, and then I go to my folder and I open the folder, and there it is. So I've got my coordinates, make it a bit bigger. I've got my coordinates. Okay, I've got my point. I've got my 4 statistics for each time series variable. My 4 descriptive statistics for my time series variable, which is sum, average, median, and coefficient. That is for snow cover, SN. Then for temperatures, maximum temperatures. Then for minimum temperatures. Then for participation or rain. Then for wind speed, and you see here comes my terrain ones: elevation, hillside, aspect, terrain 1, which is again elevation, terrain 2, which is 51, that is the slope, sorry, and then terrain 3 is 130, which is that one, and this is the aspect ratio. No, that's the aspect ratio. I don't know what the 88 is. I was going to figure out. And there's my normalized difference, snow index variables as well. So there's my time series. Okay, so it's for the snow, it's from daily data from daily data to monthly data, from monthly data to a median descriptive data. And for my environmental ones, it's from monthly to a descriptive. And then for my topography, it's a value as is. There's no point to reducing because it's a singular image. So there's the data set that I'm working on now. This is cross-section data. It's not time series data. It's not panel data. It's cross-section data because there is no time associated with this per se. Although the data comes from time, we don't look at it over time now. We're simply just looking at the values as in a particular point in time, how they correspond with one another at a particular point in time. And this period of time would be equal to the topography period. Okay, so that's plus minus what we're working at. Okay, so everything that we've done so far culminates in this spreadsheet. Now we can do some work on this using either our pivot tables. We can graph them. We can do some basic regression by using our data analysis stuff of this. So it's another lot of things that we can do in Excel with this. Really a lot of things what we can do with Excel with this. However, what I want to do is take it one step further. I want to go into RStudio. Okay, so you get the idea. So we generate the data and we generate the images in Earth Engine. We take the data and the images to QGIS. In QGIS, we refine the data, we make it a bit pretty, and the variables that we don't have the data, we generate the single images, we generate that data, so we expand on the data set, and then once we have our expanded data set that have the data for all our variables, whether it's in descriptive format or singular format, we then export it into Excel. Okay, and we can now do a whole lot of things in Excel, but let's leave that for another day. What I want to do now is I'm going to save this as a CSV. So I'm going to save as, go to my folder, and I save it not as a workbook, as a CSV, comma delimited. Now I've already done that, and it sits in my data sets. Well, it's in my folder. Anyway, let's quickly go there, make it bigger, show you. It's there. It is where it is. Is this? Where is it now? Oops, why is it snow? Why can't I find things when I'm looking for it? Snow cover, there it goes. Short cover, short QGIS, there it sits. If I open it, okay, it's read only because it's there. You can see there, X and Y, X and Y. You can see there's some snow, average, so medium, etc. And there's my terrain ones, my elevation, hillside. So I've converted it into, I'm going to save it. I've converted it then into CSV format, and there it sits. Okay. So what I'm going to do in the next video is just to basically bring it into RStudio. Okay. So in that next video, we're going to just put it into RStudio, and we're going to play around a little bit in RStudio with it, etc., etc. Okay. So that would be installment, what's it now, X of our pipeline. Okay. So remember, as I said, we bring in all our data sets into Earth Engine. Okay. Some of them are time series, some of them are singular. We bring our region of interest and we bring our 100 points. Within that, we generate time series data for each of my 100 points based on the variables that are in time series format. And we generate singular images. And then we move everything into QGIS. And QGIS, we take the journey a bit further. We go one step further, we clean up our database. And those variables that we haven't generated data for the 100 points, we do that using the sample raster function. Now I have a data set, a polygon data set with 100 points with all the data that I require. Descriptive data sets for the time series variables and singular data sets for the topography for the single image. And I export everything into Excel. In Excel, I can still make it a bit more pretty. I can change a little bit. I can change the names, whatever I want to do in Excel. Okay, but predominantly I'm checking my data, making sure everything is sorted, and then I save it as a CSV file. Once I've saved it as a CSV file, I then want to bring it into RStudio. I want to then bring it into RStudio, because in RStudio I want to do a couple of things that I cannot do, for example, in either Earth Engine or in QGIS or in Excel. So each of these programs has its, in my books anyway, have its niche area. Okay, so I'm not trying to do everything in Earth Engine. It may or may not be possible, but I'm not doing anything. Don't want to do all the thing in Earth Engine. I also don't want to do everything in QGIS. I also don't want to do everything in Excel. I also don't want to do everything in RStudio. But I use them in a complementary way, not in a substitution way, but in a complementary way. They keep on building because I feel comfortable. They have specific characteristics that allows us to do more, better looking things than maybe some of the other programs. So that's my pipeline. Okay, I can still bring Geoda in here because Geoda also has some functions that I can do that is easier or best suit for Geoda than, for example, that. So I think you get the idea. So it's Earth Engine. Everything starts there. That's where your journey starts. Then typically you go to the next destination, which is your QGIS. And typically from QGIS, you go to Excel. And then from Excel, okay, you can either branch into Geoda or you branch into RStudio. If you want to do, let's say, cluster analysis and things like this, I go to Geoda. If I want to do regression and correlation and this type of work, I go into RStudio. Okay, so Earth Engine, QGIS, Excel, Geoda, RStudio. That is my platforms that I work with, and I've developed a way of seamlessly moving from one to the other and vice versa, almost like in a singular, circular format. Enough blah 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 for now. Okay, so let me pause there for now. I want to spend a bit of time in the next video tutorial on RStudio because we haven't touched RStudio again. So as I said, from now onwards, our work in Earth Engine will be in terms of images and data, and then we start incorporating more of the other platforms in these video tutorials, as I said, to illustrate the pipeline or to illustrate the journey from beginning to end. Okay, well, thank you very much. I really appreciate your company. It was great having you aboard for this video tutorial. I hope you understand. I'm hoping I'm making sense. I'm hoping you're learning, and I'm hoping you're gaining some motivation to also tackle these things and to run with them, because it is a journey into the unknown. It's really a journey into the unknown, and as you can see, there's no end in sight. This thing can go on and on and on and on and on and on and on. But it makes life interesting. It keeps one mind occupied and healthy. Anyway, please remember to like. Please remember to subscribe. Please remember to share the video. Please feel free to send me comments. Much appreciated. All the thank you notes, and this is really, it keeps one going. It keeps one going because the journey can become tedious, but this keeps on going. So please be on the lookout for the next video tutorial. It's on its way, and I'll see you on the other side.